The first step is to blow the bulb. I've been using 8mm diameter light wall soda lime glass tubing. The lathe is a very old Unimat 3 and is designed for metalwork. I made the white support from PTFE rod. It has to be accurately aligned. The blowing is done using a hand-pumped device called a mini-lung from Neon Works. The other end of the tube is plugged with a rubber bung. The torch is just a common blowtorch using a butane-propane mixture. The bulb is blown in 3 stages. First 2 small bulbs are blown, very close together. They are then merged to make one larger bulb. The tube where the electrical connections will be has to be cut very close to the bulb. To do this, it is first accurately scored all the way around with a knife. To sever the tube, the scratch is first moistened and then heated with a hot nichrome wire. The wire is heated by a high electrical current from a homemade power unit. The other end will become the exhaust tube for attaching to the vacuum pump. In a later stage, all air is removed from the bulb to prevent the filament from simply burning out. To facilitate sealing the exhaust tube, it is necked down at this stage. A bead of glass is applied to the electrical wires just below where the filament will be to keep them the correct distance apart. The wires are then crimped onto the filament, which is made from 25 micrometer diameter tungsten wire. This stage is very fiddly. The wires are then sealed into the bulb. The white ceramic tube is to prevent the wires from burning in the flame. The expansion coefficient of the wire has to match that of the glass and also bond well so that it is gas tight. It is a special type of wire called Dumet and was purchased from JLC Electromet. The hot glass tube is squashed onto the wires using graphite. The thickness of the glass now varies from less than 0.2 mm in the bulb to around 2 mm in the seal. If it is allowed to cool naturally, it will crack. To prevent this, it has to be annealed. The annealing oven, which is also homemade, is raised rapidly to 530 centigrade and then ramped back down at a controlled rate. The lamp is then ready to be attached to the vacuum pump. You may be wondering why the oven is on top of the vacuum rig. I designed the annealing oven in this way so that it can double as a bake-out oven for higher vacuum devices such as triodes at a later date. At this stage the filament is lit to test it and also to flash off contaminants. The exhaust tube is then closed and the completed lamp detached. Lamps using the 25 micrometer tungsten wire work well at 180 to 190 milliamps. The voltage depends upon the length of the filament. This particular lamp requires 9 volts.